Hello, folks. We're going to talk about test 3. We're going to run through test 3. Here's the actual answers for all of test 3. You may be working this out on your own, but for your test corrections, but here's what I actually was designing. So starting with our valid loose structure. Selenium. Selenium is group 6. So it has 6 electrons, and there's 6 from each of the oxygens. And there's 2 from the negative charges. So 18, 20, 26 electrons. Start with selenium in the center. There's 6. And I put lone pairs on everything. There is another 24 electron. That's 24 electrons used. So that means you have to put the last lone pair on selenium. An alternative that minimizes the formal charge is to put a single, only one single double bond to selenium. However, selenium still receives its lone pair. Either of those structures would have been valid. This double bond could have been anywhere, but there should have been, if you did a double bond, the oxygen should have 2 lone pairs. And there should be 1 lone pair on selenium. Any of those would have been valid. That's all 26 electrons. And this one has selenium with an octet. This one has selenium with an expanded octet, but that is allowed. Balancing this equation. So I would start with, if that's 1, that is 3 carbons, 3 carbons. That's 8, so I need that to be 4. 4 times 2 is 8. So we have 3 times 2 is 6 oxygens, and plus 4, that's 10 oxygens, so that needs to be 5. Balance equation is that. When calculating formal charges, you compare the electrons on the atom versus the electrons that should be there. So carbon is group 4, nitrogen is group 5, oxygen is group 6. Carbon, we see 1, 2, 3, 4, 5. Carbon experiences a -1 formal charge. Nitrogen is group 5, 1, 2, 3, 4. It experiences a +1 formal charge. Oxygen is group 6. It sees 1, 2, 3, 4, 5, 6, 7. So we have the formal charges are negative, positive, negative. And -1 plus +1 minus -1, net formal charge of -1. Those should match up. Last problem on the first page. How many sigma bonds and how many pi bonds are in trinitrotoluene? TNT, dynamite. Each of these lines is a bond. So let's count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. 21 single bonds. Now, every bond that has a second bond, so that's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. 21 sigma bonds, 6 pi bonds. Draw a valid Lewis structure for this compound. CH3, CH2, N, H in parentheses, CH3, ethyl methylamine. So there's the amine is the nitrogen. So we have ethyl, C, H, 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 C, H, H, bond to N, H, lone pair, C, H, H, H. There's only so many structures you can do with this. You are not allowed to make 2 bonds to an H. Nitrogen should have 3 bonds in a lone pair. There's only so many ways. You break it down. Group, group, group. I put the H separate so you wouldn't try to make that bond to there, but you know. This is an ethyl group, which is a 2-carbon group. A methyl group is a 1-carbon group. And amine is this NH group. Now this one, if you tripped up, I'm sorry, you did not read. Electron geometry or electronic geometry is the initial geometry before you put in, where you count the lone pairs the same as you would count everything else. So we have 7 times 4. All these are group 7. So you have a total of 28 electrons. So Br in the center, F, F, F. There's 6. Lone pair, lone pair, lone pair, lone pair. With 3 of these, that's puts it at 24. So that means lone pair, lone pair. So how many things are coming off the bromine? 1, 2, 3, 4, 5. Now you may have been correct that it is T-shaped molecular geometry, but in terms of electronic geometry, it is trigonal bipyramidal. Now, identify the following reactions as either combination, decomposition, single displacement, double displacement, or combustion. Single displacement is when one element displaces a compound, and we have lead and gold displacing each other. So that's single displacement. Combination is when 2 things become one. Water and sulfur trioxide become sulfuric acid. That is combination. Decomposition is when one thing breaks down into 2. So hydrogen peroxide is a decomp. And combustion is when something reacts with oxygen to form the oxide. Carbon, which is essentially coal, burns an oxygen to form CO2. So this should have been combustion, but I accepted combo as well, because truly combustion is usually just a form of combination. Now, this was not meant to be hard. Strong acid, strong base. You look, anything with nitrate splits up. Anything with hydroxide, well, anything with group 1 metal splits up. Water is a pure liquid. So what do you have when all things canceled out? You have H plus OH minus goes to water. I accepted this without the without these phases, because I mean, hey, if you got what it split into and the net ionic, it's good enough. Now this guy, read it. Which element is oxidized? If you figure it out, Na is usually +1, +1, -1. O is almost always 2 minus. H is always +1. Cl is 0. O is 2 minus. And H is +1. And this guy, because of that, -2, -1, this chlorine has to be +1. Now, because of this, there's a chlorine that goes from +1 to 0, but there's a chlorine that goes from -1 to -1, and there's a chlorine that goes from -1 to 0. So this was kind of a little tricky, but kind of not. The only thing that changed at all in this reaction is chlorine. Chlorine was oxidized, chlorine was reduced. The only element that changed its charge was chlorine. One of the dead giveaways was chlorine was a pure element there. But yes, that was a little tricky. Almost done. Which of the following half reactions would occur based on this activity chart? The element higher up will displace will become a compound with anything lower down. So we're comparing silver to H, zinc to iron, and barium to H. So silver is way down here. H is there. So will that happen? No. Zinc, way right here. Iron, right there. Zinc is above iron. So barium, right here. H is right there. So will that work? Oh, 2 and 3. 2 and 3. What is the molecular geometry of sulfur chloride? Sulfur is 6. And 1, and there's 4 times 7. So 28 plus 6, so 34. Chlorine. There's 8. Plus 24 puts it at 32. And so we have to put a lone pair on sulfur. How many things coming off sulfur? 1, 2, 3, 4, 5. Most people got this one, but with 5 coming off, it has to be sawhorse. Number 12, the last one on this page. Which of these compounds contains a molecular dipole? So we need a polar element and a degree of asymmetry where it's not the same on both sides. All these guys have polar elements. However, the question is whether they have symmetry. This one has a mirror plane right in the middle, so that one's out. This guy is out because this guy cancels this guy. These 3 guys all cancel each other out. So this guy, I put the carbon there to try to help you see that's supposed to be a carbon. But if you look right here, no mirror right there, no mirror. These H's are not the same as these F's. So which one has a dipole? You draw a plus and the arrow is going right down between it. I told you there'd be something like this. Draw the alternative resonance structure. So literally this lone pair is going to swing here. And this lone and this double bond is going to move to there. The correct answer should have been. So I'm going to start with my same base structure because the resonance structure, the shape stays the same. You draw a lone pair there. A negative charge there. You didn't have to circle the negative charge. Boom. That's all you needed. This guy, you look up the structures, iron and sulfate, soluble. Barium chloride, soluble. Iron chloride, soluble. Barium sulfate, insoluble. All said and done, iron cancels out, chloride cancels out. The structure you should have had is something like this. So you want the net ionic, so it shows what is happening. We are forming a solid. Label the hybridization. Hybridization is we go from the sp all the way to the sp3d2 based on how many sigma bonds are coming off of the compound. 3 plus 1. So this carbon has 4 things. 4 things means it's sp3. The sulfur, I know it has 2 double bonds and it makes you want to say sp3d, but it's really 1, 2, 3, 4. 4 things, sp3. This guy, 1, 2, 3. 3 things means sp2. And this guy, 1, 2, 3, sp2. Last problem in the bonus. So acid base is, there was a typo here. There's always a typo. Oh, it's supposed to be HCl. H plus OH goes to water and acid base. Salt metathesis is solid forms. And redox is charge changes. I told you specifically how to find a redox. So this guy, this is an acid, but this is not a base. What you have, if you check the solids, this guy is a solid. So it's a salt metathesis. This is a pure element. This is a pure element. So this has gone from 0 to 2 plus. This has gone from +1 to 0. This is a redox. I told you how to find them. Look for the pure elements. HCl plus NaOH, that is the only acid base. And this guy, MgOH, this is a base, but this is not an acid. This is a solid right here. So this is a salt metathesis. And the bonus, this was one we did in the lab. So that's 8. 7 times 4, that makes that 28. So 28 plus 8 is 36. What you end up having, radon, chlorine, 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 chlorine. That's 8. Here is 24. That brings our number to 2. And then lone pair. This guy is square planar. That's a molecular geometry. That was the test.